Last problem. Woo! And I think the last video I'll be recording this year. Hopefully. Anyway. Okay, 78. So we got a 200-meter wide river. Let's draw this whole picture. So this is the shore of the river. The water is in here. Ground up here. Ground here. So it's 200 meters wide. We got the river flowing, let's say this way. Velocity of the water is 2 meters per second. And then we've got a boat starting at the southern shore, the south bank, and heads 30 degrees west of north. So the boat starts here, and here's north, so it goes 30 degrees west of that, and that's that way. So the boat heads in that direction. Yeah. And it gives us the velocity of the boat with respect to the water as 8 meters per second. We can say this is the velocity of the water with respect to the ground, just to be consistent. So as you can probably guess by now, I'm going to logic my way through this, but also sort of use the notation that we used in the equation that the book gives, but with actual letters that make sense. Alright, part A. We need to find, part A and B are sort of together, the magnitude and direction of the boat's velocity relative to the ground. So, two things to notice. We can, as we normally do with 2D motion, we can split up the motion into an x and a y component. So the y velocity is the 8 cosine 30 because it's adjacent to the 30, and the x is 8 sine 30. Excuse me. But the other thing to notice is that the y motion of the boat is perpendicular to the river motion, and so the y motion is unaffected by the river motion, right? Whereas the boat is essentially going upstream in the x direction because the river is flowing to the right, the boat's flowing to the left in the x direction, so they're fighting each other, and so we need relative motion there. So let's do y first because it's a little more straightforward. The velocity of the boat with respect to the ground in the y direction, well, since in the y direction the water and the ground are not moving relative to each other, then the velocity of the boat with respect to the water and the velocity of the boat with respect to the ground are the same, right? So we'll just use the velocity of the boat with respect to the water, and that will be also the velocity of the boat with respect to the ground. One more time, that's because in the y direction there's no flow of the water, so essentially there's no motion relative. There's no like VWG in the y direction. It's only VWG. V velocity of the water with respect to the ground is only in the x direction. So this is 8 cosine 30. Again, cosine because it's adjacent. So that's 6.93. What did I do? What would I do? 93 meters per second. And let's just call that J for the fun of it. Velocity of the boat with respect to the ground in the x direction, well, we're going to logic our way through it, even though essentially by doing that we're using that equation in the book. But we got, and oh yeah, forgot. Let's call this positive and this negative. So, and obviously it looks as though we called up positive as well, so I might as well just to be completionist. So this is going to be negative 8 sine 30, because the boat's speed is to the left, plus the river speed 2, right? Because the boat is fighting the river, so someone standing on the shore will see the boat trying to go up with this part, negative 8 sine 30, the river pushing against it 2, slowing it down by 2, and so this equals negative 2 meters per second I. So in other words, the boat is going fast enough to actually move down upstream. In fact, its x component looks like it was negative 4, so it was going twice the river speed in the opposite direction. So yeah, now we can combine to get the actual magnitude, combine components. So it looks like we got whoa. The y velocity is 6.93, and the x velocity is 2. I'll just eliminate the negative because of our diagram. We know it's evident. And so, little Pythagorean theorem, we'll just call this V BG. So V BG equals the square root of 2 squared plus 6.93 squared. And that is 7.2 meters per second. Direction, we'll just do inverse tangent. Opposite, which is this is our angle, this is our 30, so opposite is the 2, adjacent is a 6.93, and so that's 16.1 degrees west of north. Oh, that's off screen, isn't it? So that equals 16.1 degrees west of north. Looks like it cuts off at about here-ish. I'll see on the final edit. Alright, so that's parts A and B, magnitude and direction. What's part C? How long does it take the boat to cross the river? So C is the time it takes the boat to cross the river. Well, the boat's going at a constant speed, so no acceleration. Speed is just distance over time. Time is distance over velocity. We only know one distance, and that's across the river. That is the y distance, the vertical or j component of the distance. So we could use the speed of the boat in the y direction to figure this out. So in the 200 meters across, the boat is going at a speed of 6.93, as you can see up here in the y direction. Right, the x velocity has nothing to do with going across the river, and that gives us a time of 28.9 seconds. And it doesn't ask, the problem doesn't ask this, but now that we know the time to cross, that's also the time it takes, also the time that the boat moves down or upstream in the x direction. And so with that time, we could actually figure out how far upstream the boat moves, right? Same idea, but we'll find d. Velocity is 2 because that's the speed in the x direction, and then same time as for the y velocity. All right, so those are all the sample problems. I can't think of anything else I want to add, but yeah, if you have any questions, let me know in class. And I think this is the last video I need to record this year. You guys got to hear me record a video, yay. Okay, bye bye.